All right, you guys. Today we are going to continue converting points, but this time we're going the other way. So we're starting with rectangular points in XY format and converting them to polar or theta format. This is a little bit trickier because of the fact that polar has an infinite number of points that can be in the same spot because of all those different angles that land in the same position. So we'll talk a little bit about that. Before we start converting, we need to know a couple more equations here. So from the last set of notes, we already know that cosine of theta, that x equals r cosine theta and y equals r sine theta. Now these are good for our other way of converting, our other direction, but this time I want r and theta, so I need equations that have something equal to r and something equal to theta. So looking at that picture from last time, like if, let's say this time I have a point, xy, we know our vertical is y, horizontal was x. I want it to be written as a polar point. That's in r theta. Theta is the angle, r is distance from the pole, the radius. Okay. Now a couple more things we know from our trig units. This right triangle here, we know the Pythagorean theorem tells us x squared plus y squared equals r squared. So that's pretty close to r being by itself. To solve this one, I can just square root both sides, leaving me with square root of x squared plus y squared equals r. Now be careful here, you cannot write x plus y equals r. Because of the addition in the middle, we can't split up that radical, so we just leave it exactly like this. And the last trig function we haven't used yet is tangent. So let's see what happens if I set up tangent of theta on this triangle. I get opposite over adjacent, which is y over x. Now if I want to solve this equation for tangent, for theta, I can do the inverse tangent of y over x, so inverse of the ratio, to get the angle measure, to get theta. So now I have two equations that have r by themselves and theta by itself. So in total, these four equations, we're going to use the entire unit here. So we'll definitely use these guys a lot. But today we're focusing on the bottom two. So let's look at some examples. Here I'm converting to polar. So it's currently in rectangular, x and y. So we have our two equations, x squared plus y squared equals r squared, and theta equals tangent inverse of y over x. Oops, sorry. So it's a little bit more complicated here because of the different angles. So we're going to have 3 steps every time. Step 1, we're going to plot the point. Now, I don't care about it being exact. I only care about the quadrant this point lives in. So over to up to would put me in quadrant 1. It doesn't matter where you put the point as long as it's in the right quadrant. That'll come back later for our angle measure. Step 2, we're going to figure out r. So we're going to use, this should be just r over here, not r squared. So we're going to use our equation, r equals the square root of x squared plus y squared, to plug in our values. So we have x and y, so we can write r equals square root of 2 squared plus 2 squared. So r equals square root of 4 plus 4. R equals root 8. I'm fine if you stop there. You can simplify this to 2 root 2. Either way is fine with me. So now we have r, which is good. That's half of our point. We also need theta. This is the trickier one. So theta equals the inverse tangent of y over x. So when I plug that in, I have inverse tangent of 2 over 2, which is inverse tangent of 1. 2 over 2 is equal to 1. This is something from a unit circle. You're thinking to yourself, what angle has a tangent equal to 1? From the unit circle, the first angle that has that is 45 degrees. Now, this is the tricky part. Whatever angle we get here needs to be in the right quadrant. So we might want to write a note, must be in the correct quadrant, meaning it has to match the quadrant from step 1. 45 degrees is in quadrant 1, so we don't have to worry about anything like changing the angle. We'll see some of those later. So I am done My final point is 2 root 2, or root 8, comma, 45 degrees. Okay. Let's see another example here. So again, x and y. I want to plot first. So over 2 down 3 puts me in quadrant 4. Then I'm going to solve for r, x squared plus y squared, square root of x squared plus y squared. So r equals 2 squared plus negative 3 squared, all under the radical. Square root of 4. Negative 3 squared becomes a positive 9, so be careful there. So therefore r equals root 13. And step 3, I have theta equals tangent inverse of negative 3 over 2. So now when I look at this negative 3 over 2, that's not something from my unit circle. It's not a tangent value I'm familiar with. So we're going to use our calculator to evaluate that. To type it in your calculator, you're going to click second tangent and then negative 3 over 2. You should get an answer in degrees of negative 56.31. You'll want to make sure your calculator is in degree mode, not radian mode when you do this. So again, I need to check that this is in the right quadrant. So this is a negative angle. So like we talked about before, negative and positive angles are above and below each other. So positive 56, we know that's in quadrant 1. So negative 56 should be right below it in quadrant 4, which is what we want. So I'm good to go. Root 13 and negative 56.31 degrees would be an acceptable answer. There's actually many answers you could give for any of the polar points, but this would probably be the easiest one to list. Let's try one more together here. So we have our x and y again, plotting this point. Again, who cares where it is exactly as long as we know the quadrant. So it's negative, positive. So negative is left, positive is up. So it's in quadrant 2. Now I'll solve for r. So r equals square root of x squared plus y squared. R equals square root of negative 3 squared plus root 3 squared. Negative 3 squared is positive 9. Root 3 squared is just 3. Gets rid of the radical. So r equals square root of 12. You could simplify that to 2 root 3. I would be totally fine with either answer. At this point, either way is fine with me. Step 3 here, let's see what happens when we do theta. So tangent inverse of y over x. Theta equals tangent inverse of root 3 over negative 3. So this is something from my unit circle. So I'm looking for where tangent is equal to negative root 3 over 3. That happens in 2 places on the unit circle. So the 2 options we have are 150 degrees or 330 degrees. Now remember, we want to be in quadrant 2. So that means we're going to eliminate 330 and we're going to use 150 degrees to stay in quadrant 2. So my final answer, 2 root 3, and 150 degrees. Okay, if we use 330, you could, but you would have to make the radius negative, right? Because remember, you want to land in the same spot as your original point. So the easiest method is just to use an angle that gets you to the right quadrant, and then you don't have to worry about changing the radius. Okay, let's look at one more here. I'm actually going to pause the video. I want you to at least do the first 2 steps, and then we'll do the angle part together. So pause the video for a moment, see if you can at least figure out the radius, and then play the video and we'll do the angle together for this one. Are my first 2 steps for the part D here, the last problem. So this point is in quadrant 3, and I got a radius of root 89. Okay, my last step here is figuring out the angle. This one's a little bit tricky. So if we plug in our values, inverse tangent of negative 8 over negative 5. Again, we have to type this one into our calculator because this is not on the unit circle. So theta equals 57 0.99 degrees from the calculator. Now when I look at this angle, 57.99 is definitely not where we want it because this is in quadrant 1. I need the angle to be in quadrant 3. So if you look at this drawing here, it can help you see what we might have to do. I need to figure out how to get all the way from the first quadrant to the third. Drawing this semicircle here helps us see that we can just add 180, right? I'm going halfway around from quadrant 1 to 3. That would be halfway around the circle. So if I take 57.99 and I add 180, I'll end up with an angle in quadrant 3. When I do that calculation, I get 237.99, and that works as my angle down here in quadrant 3, because remember, it has to match the quadrant we started with. So my final polar point is root 89, comma, 237.99 degrees.